I'm Dr. Chris Griggs. I'm the principal investigator of this project. It's a water reuse project. What we're looking at is developing strategies for water reuse by diversifying our water portfolio. And that includes sources such as gray water, storm water, and whatever other sources of water that we don't typically use. And so what this is a pilot that's composed of ultrafiltration and reverse osmosis. It's funded by ESTCP. And we're doing the dim valve here to increase the maturity of this type of technology, to recommend what types of technologies will be used in the future to enable access to water for everybody who needs it. This site is ideal because it's realistic training conditions, realistic feed water. A lot of the studies in the literature that are out there and the data that's existing is based on lab simulations. This is real gray water that is captured from real training exercises, and it's source separated. There is no black water because there are no bathrooms in there. So it's just shower water. So we've isolated that, so we're doing a very deep, detailed study on just what is gray water and how do you treat it. And this is one of the few places in the world that you can do this. We have high volumes. I think this is probably the highest. We treated over 100,000 gallons here. Probably the most real gray water has ever been tested and treated in this type of study. And so Camp Shelby has been gracious enough to host us and been very helpful in this. And its proximity to ERDIC allows us to get more bang for our buck for the sponsor, because we can get down here in a couple hours and respond to the operational tempo.
Camp Shelby is a joint training center. It's the largest National Guard installation in the country. We train a little over 100,000 soldiers, airmen, sailors, Marines a year. It's 136,000 acres. We can house up to 12,000 soldiers here at Camp Shelby. We have huge training exercises here, XCTCs, CTCs. So this is where testing can be done and be really relevant because of what we do here at Camp Shelby. So this is the perfect site to test at.
Well, this is a prototype system that we've developed for the Army to be used on contingency base camps and allow them to take water that is being currently in most base camps. Water comes into the system, gets treated, gets used in the showers or laundry, and then taken off base and disposed of, usually like in the desert in Iraq. They were just thrown away in the desert. However, with this system, we can recycle and reuse that. We can treat the water and bring it back in and reuse the same water for the showers and the laundry, therefore saving transportation costs, security costs, and just the cost of obtaining the water. And it's also really good for like low water environments where you have trouble bringing in fresh water. That way you can just reuse the same water over and over again.
All right, so the components are, we're taking some unique waste sources of water, different feed quality, because we have storm water, we have shower water. Basically, where we're intercepting it, we're putting it through ultrafiltration. From there, we take that to go through reverse osmosis, and then from there we use UV disinfection. And there we have a really high quality effluent that we store in our blivet, and that is our final product, and that's our key sample for the project and the metrics that we're trying to go, because we're going for a high quality effluent.
It goes through a series of different aspects. Right now, we are treating with an ultrafiltration system, which takes about 90% of the contaminants or particles, different chemicals, and then it goes from there into our RO system, which removes the rest of the stuff, and then finally it goes through a UV, which removes a lot of the bacteria and stuff. So essentially we get it's very close to potable water, and we can add chlorine and other things to make it even potable water in the future.
So the purpose is we're trying to diversify our water portfolio. We want to know in the future what sources of water can we unlock and use. Can we use gray water? Can we use storm water? Should we blend those? Is it going to be desal? Is it going to be atmospheric harvesting? What makes the most sense from a techno-economic point of view? And so what we're looking at is, we're looking at the water quality, defining that water quality, and optimizing the treatment strategies to produce the highest quality water possible. And ultimately what we want to do is we want to ensure that the future has access to clean water by defining how safe is safe and guiding those regulations and policies that are going to give us the framework to reuse water in the future. So ERDIC is uniquely suited to solve this type of problem because we bridge the gap between academia and the private sector. We can come in and build these prototypes, or we can modify the prototypes to customize them in a way that we're honest brokers. We're not selling the prototype, but we are going to be the ones that are going to deliver the data and the honest message. This is the right way to do this and provide guidance for our policymakers and Army Public Health Command and these types of people that are going to make these ultimate decisions on what we can use this water for. So us coming in and doing this, we have the unique ability to either build our prototypes or modify an existing prototype to meet the specific project need.
I see this from a twofold concept. What comes to mind immediately to me is disaster instances, and I refer back to Hurricane Katrina. This system being put in a state emergency duty package to recycle water for showers in an emergency situation that has to be put in quickly, deployed quickly, not only for the military force, but the civilian sector as well.
So the warfire is absolutely critical. It's become, our model of water is unsustainable. We have a finite amount of water that comes out there, and it has a minimum lifespan. Water is one of the heavy signature burdens. It's very heavy. And so what they want to have is, so from an expeditionary point of view, they want to be self-sufficient for 7 days. And that's a lot of water for 3,000 people for 7 days. Dropping pallets of water in single-use plastic has become environmentally unacceptable. But we have to hydrate our soldiers. Soldiers have to have access to water for hygiene, personal health, and hydration. So hydration challenges are going to be a big problem in the future. We want to make sure that we have the water to support our troops. And so if we can find a better way to get that to them, then this is going to be a great technology for them.